Homework 3, Part D, write an Excel VBA function calculating the Darcy friction factor using Churchill's equation, valid for both laminar and turbulent flow regimens. With this, calculate the pressure drop across 100-meter long, 0.2 meter diameter pipe with a relative pipe roughness of 0.0001 when water flows through at 0.1 meters cubed per second, assuming electricity costs 15 cents kilowatt hours. How much would it cost to operate a 100% effective pump to maintain this flow for 2 hours? So let's go ahead and look at what we have. So right now, I'm going to be using a code that we worked on in class. Also, I'm sorry, Carlos. I do not have two angles. I don't have any way to film it. So this is what we have from class. This is our Darcy function. We have T1 and T2. And then our Darcy F. So I am using the code for class. And this is our Churchill equation as well, and we're going to be using this to solve our problem. So we have all of our variables typed out so far. So I already went ahead and put in our givens that were given in the problem, like pressure drop, length, diameter. It's all already put in. Okay. So, I hope you know, like when I look down to type this, I cannot type looking up. So that is why I'm doing that, and I'm sorry I don't have another angle. So to start with our V dot, it is going to be equal to Q dot over 3 parentheses over 3.1416 times D dot squared over 4. So next we're going to be moving on to our Reynolds number, and this is going to be equal to rho times B dot times D dot parentheses over mu. Dot over mu. So the ED is the roughness of the pipe, which is given. I just forgot to put it in, which is 0.1. So now we're going to be solving our pressure drop, which is the roughness of the pipe. We're going to be using the macros that we created. So it's going to equal Darcy F. This is going to be times our length divided by our D times rho times our velocity that's squared divided by 2. Okay, now that we got that to work, now we're going to convert it to atmosphere. So we're going to take our delta P, equals delta P divided by 1.01235. Now we're going to convert it to PSIs, which is going to be equal to this number times 14.7. We're going to calculate our power, which is going to be our flow drop times our flow rate, which is Q dot. Now we're going to convert it to horsepower, which is our power divided by 476. Power dot. Caps lock is also on. No. Power dot. Okay, there we go. I lied. Our power is not 47 divided by 476, it's 746. There we go.
And so
Is going to equal 2 times 3,600. Go back. Finally, we're gonna calculate the energy because the energy is related to the cost. So we need to find the energy to find the cost. Okay, now to get our joules, it is going to be equal to power times duration.
calculate the kilowatts per hour.
Okay, so now we need to convert it to kilowatts. So we're gonna take this and then divide it by 36. 1, 2, 3, 4, 5. Okay. Finally, to get our cost, we're going to divide this number by 0.15. And we have our cost.